Hello students, let us continue our discussion on current electricity. Today we shall take few more problems. Okay, we'll try and solve 4 to 5 problems today as usual. So to begin with, question number 19 from page number 155 is as follows. 19th one, a uniform wire of resistance 12 ohm is cut into 3 pieces in the ratio 1:2:3 and are connected to form a triangle. A cell of EMF 8 volt and internal resistance 1 ohm is connected across the highest of these 3 resistors. Calculate the current through each part of the circuit. So in the first place, what we have is a single wire with a total of 12 ohm resistance, right? And this wire, okay, is of certain length, and then it is cut into 3 parts. Okay, in what ratio are the pieces there? The ratio of the pieces are 1:2. Okay, this is not 1, yeah, 1:2, double of this, then is to 3. Okay, 1:2:3 is the ratio in which they are cut. They are not the actual lengths, they are the ratios with which the entire wire of certain length is cut into. Now, see, before cutting, let us assume the 3 ratios like this. Okay, the first part, let us assume that it has the resistance of X ohm, and the second part obviously will have the resistance of 2X, isn't it? Why? Because it's only the length which is getting doubled, and it's the same wire. Row remains the same. Area of cross section doesn't change. Area of cross section remains the same because it's the same length, same wire taken. But the length is getting doubled. Once the length gets doubled, the resistance of the wire gets doubled because R is directly proportional to L, and A and rho are independent here. Okay, they're not changing. And similarly, the third part will have the resistance of 3X, right? Now, the total resistance of the wire given is 12 ohm, right? What is the total resistance? See, these 3 parts connected in series will give the total resistance of the wire, isn't it? There are 3 parts connected in series. So, the total resistance is X plus 2X plus 3X because they are in series, right? Before cutting, we are assuming the ratios, which is equal to 6X is equal to 12 ohm. So X is equal to 2 ohm, right? X is equal to 2. So when X is equal to 2, why are we doing all this? Because we want to get the resistance of each part of the full wire. Okay, so now we got the idea. So the first part has the resistance of 2 ohm, the second part has the resistance of 4 ohm, third part has the resistance of 6 ohm. Okay, so now this gave us the idea about resistance of each part of the wire. Now in the reference, what they have taken is the different approach. The total of sum of the ratios is taken 1 plus 2 plus 3, which is 6, and then it is divided. Okay, it's actually the same way. It's a bit different kind of mathematics that they had chosen, but this is also fine. Okay, you can stick with this. Conceptually, it will be more clear. So you have the resistance of each part now, which is 2 ohm, 4 ohm, 6 ohm. Then what happens? These individual parts are connected to form a triangle. So let me draw the triangle. Okay, this is how the triangle might look like. So this is of 2 ohm. Okay, in order to represent, let me draw a resistance. Let this be the 4 ohm one, and let this be the 6 ohm one. Okay, these 3 parts are connected to form a triangle, right? Then a cell of EMF 8 volt and internal resistance 1 ohm. This is the characteristic of the cell. Cell is of 8 volt EMF and 1 ohm internal resistance is connected across the highest of these 3. Which is the highest of these 3? 6 ohm. So, and according to the given data, a cell is connected across this highest resistance. So what is the characteristic? 8 volt EMF and 1 ohm internal resistance is the characteristic of this cell. Okay, this is how the circuit look like. Now what we need to calculate is current through each part of the circuit. Okay, which means current through, say, how many parts are there in the circuit? One is main current, that will come here I, and then this main current will split into two parts. I can call them as I1 and I2, and then they combine together to form I again and come back to the battery. So in total there are two parts of the circuit where two different currents are flowing. Even if we include the main current, we have three currents to find. Okay, let us find the main current also. So yeah, this is, from now on it's the familiar problem for you. Now look, this 2 ohm, 4 ohm are in series, right? So since they are in series, I can write Rs is equal to, let me name this as R1, this as R2, and this as R3. Rs is equal to R1 plus R2, which is equal to, R1 is 2 ohm, R2 is 4 ohm, right? Because they are in series, right? Which is equal to 6 ohm. And now this Rs and this R3 are in parallel, right? Let me write the reduced circuit now. The reduced circuit looks somewhat like this. Quite simple one. 6 ohm, and this is in total 6 ohm. Another 6 ohm here, right? Connected to a battery of 8 volt EMF and 1 ohm internal resistance. Okay, this is how the circuit look like. Now, what we actually need is current through each part. Okay, for that we'll be needing the main current. Okay, because we have EMF given, not the potential difference. If we had the potential difference directly given, we could have obtained it. But now, since we have the EMF, we'll be in need of current now, the main current in the circuit. The main current in the circuit says I is equal to E by R plus R, right? What is this R? R is the resistance of the entire combination, all of them put together. So in order to get the effective resistance, look at this 6 ohm, 6 ohm, equal resistors in parallel. So I'll directly write the effective resistance Rp as R by 2. Okay, because equal resistors in parallel, R by 2. If you have 6 ohm, 6 ohm, another 6 ohm, then it is Rp is equal to R by 3. Okay, go to the formula, you'll get it. Okay, so now Rp is equal to R by 2, which is equal to 3 ohm. So the effective resistance of the entire combination is 3 ohm, the external effective resistance, and the internal resistance of the battery is 1 ohm. So let us get the main current now. Main current will be 8 volt EMF divided by 3 plus 1. 3 plus 1 is 4, 8 by 4 is 2 ampere. Okay, so 2 ampere is the current, main current drawn from the battery. Okay, one result is found. But what we are more interested in is the currents through each section, which I call as I1 and I2. So in the reference, they have directly considered the fact that resistors here are equal, right? So the current through those resistors must also be equal. Okay, this you can directly assume and consider while solving problems. When the resistors connected in parallel are equal, current flowing through them, this I1 and I2 must also be equal. Okay, so from that condition, since R1 is equal to R2, okay, just a minute, let me write it here. Since R1 is equal to R2, I1 should also be equal to I2. It's the same current which should flow, which I can consider as some I dash. Okay, and for this point, if you apply Kirchhoff's current law, total current entering is I, total current leaving is I1 and I2, right? So I can write I is equal to I1 plus I2, and both of them are equal to I dash. I can call that as 2 I dash. What we want is I dash, right? Because if I get I dash, that will give me the values of I1 and I2. So I dash is equal to I by 2. What is I? 2 ampere main current by 2 is equal to 1 ampere. So I1 is equal to I2 is equal to 1 ampere. That's it. This is the final result. Current in each part of the circuit, in this and in this, both is equal to 1 ampere. And the main current drawn from the battery is 2 amperes. Clear with this? You can also make use of I1 is equal to I times. Are you good with that? I mean, if you can remember that I1 is equal to I times resistance of the other branch divided by R1 plus R2. Okay. Even you can make use of this. Okay. Or you can also make use of the voltage factor. Okay. The entire voltage factor. Okay. That we'll discuss. Okay. In the next problem. This method is fine. Okay. Since R1 is equal to R2, I1 is equal to I2. They must be equal. Currents must be equal when you have equal parallel resistors, which we have considered as I dash and obtained the value of I1 and I2 like this. Okay. There is one more situation. Okay. The same formula, I1 is equal to I times R2 divided by R1 plus R2. It's actually derived from the same formula which we will take now. Say, if I consider the potential difference between these 2 points, okay, this potential difference is same for the entire combination and for the individual resistor, right? For both the resistors individually and for the entire combination, it is same. So I can write Vp is equal to V1, right? V1 is the potential difference across first resistor, I can call, and Vp is the potential difference across the entire combination. Both are same, and it is equal to V2. V2 is also the same because potential difference across the second resistor is also same. Following. So what is Vp? Applying Ohm's law, Vp is Ip times Rp. What is Ip? Ip is the main current. Okay, main current through the entire combination. So it is simply IRP, which is equal to what is V1? V1 is I1 R1. Okay, and what is V2? V2 is I2 R2. Okay, even we can make use of this formula because Rp we now know it is 3 ohm. Current, main current is 2 ohm. I1 has to be found into what is R1? R1 is 6. So 6 and 6 cancels. I1 is 1 ohm, 1 ampere. Okay. Even we can make use of this method to get the current in each branch of the circuit. Clear? Okay, next question. Question number 20 is as follows. 3 resistors, 3 ohm, 4 ohm and 6 ohm are connected in parallel. They are connected, the combination is connected to a cell of EMF 2 volt and internal resistance 2 by 3 ohm. Find the current drawn from the cell and the current through 3 ohm resistance. Okay, so now we have 3 resistors directly given, 3 ohm, 4 ohm and 6 ohm. Okay, and they have also given that they are connecting the resistors in parallel, right? They are all connected in parallel like this. So I can call this as 3 ohm resistor, 4 ohm resistor and 6 ohm resistor. And then they are connected, which means the combination is connected to a cell. Okay, what is the characteristic of cell given? EMF and internal resistance. EMF of the cell is 2 volt and internal resistance of the cell is 2 by 3 ohm, right? So the cell given is of 2 ohm EMF and 2 by 3 ohm internal resistance. Find the current drawn from the cell, which means the main current I has to be found. Okay, and then also the current through 3 ohm resistor. This current, if I call this resistor as R1, and this as R2, and this as R3, I should now find I1. Okay, I2 and I3 you can calculate for your interest. Okay, it will be a practice, you do that. But let me find I now. Okay, see, you have a cell of certain EMF and a certain internal resistance, and you have combination of external resistances. This combination has to be reduced to effective resistance, and after reducing it to the effective resistance, I can get the current flowing through that, isn't it? So first I should get the effective resistance of the combination. The combination is simply the parallel one. So I can write, and since I have three combinations, I mean the three resistors, I'll go with the formula of 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. If I had only two, I would have directly went to Rp is equal to R1 R2 by R1 plus R2. But since I have three resistors connected in parallel, I'm going with this formula. Okay, this will help us in more than two combination or two resistor combination. So let me work for that. 1 by Rp is equal to 1 by 3 plus 1 by 4 plus 1 by 6. What is the LCM? 12 is the LCM, right? So 3 4s are 12, 4 3s are 12, 6 2s are 12. So it's 4 plus 3 7 plus 2 9 by 12, right? So again, I can simplify this. 1 by Rp is equal to 3 3s are 3 4s are. So that gave me Rp is equal to 4 by 3 ohm. Okay. 4 by 3 ohm is the effective resistance of the entire combination. So it's the parallel combination for now simply. So Rp is 4 by 3 ohm. And now the main current formula says I is equal to E by R plus R. What is this? E is the EMF of the cell. Small r is the internal resistance of the cell. What is this capital R? Capital R is the effective resistance of the entire combination. Okay, whatever the external resistance that you have, you should have the effective resistance of that, and that effective resistance shall be put here, which we have already calculated, which is Rp, right? So Rp is 4 by 3. Rp itself is R and it is 4 by 3. So let me work for that. So EMF is E 2 volt, R is 4 by 3 plus small r is 2 by 3, right? So it is going to be 2 by 3 by 4 plus 2, 6. So it's 3 ones are, 3 twos are, 2 and 2 cancels, and hence the main current drawn from the cell is 1 ampere. One of the result is found. Okay. So 1 ampere current is drawn from the cell. Now what we need is I1. So now in order to get I1, the last last method that I suggested, the previous problems, 19th one, last method, that will help us. That can give us the formula, that give us the solution very easy, in a very easy way. So look at this. If I consider these 2 points, voltage across the entire combination, which I can call Vp, okay, is equal to voltage across first resistor R1, isn't it? And it's same for all of them. V1 is equal to V2 is equal to V3 is equal to Vp, okay, for the entire combination, because they are in parallel. So Vp is equal to V1. What is Vp? Vp is the main current, okay, Ip I can call, or main current I can keep. Main current I into resistance of the combination Rp, okay, for the entire combination, which is equal to, what is V1? V1 is the voltage across first resistor, which is I1, okay, current through that, times R1, right? So what we need is I1. Do we have the rest of the values? Yes, we do. I, we have. Rp, yes, we have. R1, yes, we have. So let us work for I1 now. So I1 becomes equal to, what is I? I is 1 ampere. What is Rp? Rp is 4 by 3 ampere divided by R1 comes here. What is R1? R1 is 3. So quite simple. I1 becomes equal to 4 by 9 ampere. Okay. Simplify this. Even if you keep it in fraction, 4 by 9 form, that's also fine. Okay. So this is the total current which is flowing through first resistor. Okay. And for your interest sake, it is advised to calculate I2 and I3. Okay. You should calculate it. It's the extra work for you. Okay. Calculate I2, I3 in the same way. Okay. It's easy in the same way you do. Okay. Next question, 21st, is as follows. 3 resistors of resistances 2 ohm, 3 ohm and 4 ohm are combined in series. what is the total resistance of the combination? This is first part of the question. And in the second part, if this combination is connected to a battery of EMF 10 volt and negligible internal resistance, obtain the potential drop across each resistor. So first, let me work for the first part, where we are connecting three resistors of 2 ohm, 3 ohm and 4 ohm resistance in series, right? So here we have 2 ohm, 3 ohm and 4 ohm. Okay, connected in series. Okay, yeah, again, second part, let me include the second part here. They're connected in series to a battery of EMF 10 volt and no internal resistance, it's neglected. So which means that EMF and TPD are same for this particular cell, okay, for this circuit, because it has internal resistance which is negligible, okay, close to zero. So now first part of the question, they're asking us to get the effective internal resistance, effective resistance of the combination or total resistance of the combination. What kind of combination do we have? It's quite simple, series combination. How many resistors do we have? We have three of them. Let me call them as R1, R2 and R3. So the effective resistance, since it's the series combination, I can call as RS is equal to R1 plus R2 plus R3. Okay, it's for the part A of the question. And it is equal to, what is R1? 2 ohm, R2 3 ohm, R3 4 ohm. So it is say 4 plus 2 6 plus 3 9 ohm is the total resistance of the combination. Okay, quite easy, sum of them. And now in the second part, they have mentioned that the EMF of the battery connected is 10 volt. Okay, since internal resistance is 0 ohm, V is also equal to 10 volt. What is V? V is the potential difference across the entire combination. Okay, potential difference across the entire combination. And this is a series combination here. When we have series combination, the voltage is not same for all the resistors. Current is same here. Okay, the basic law you should keep always in mind. Okay, and this is the same thing which we made use of when we are deriving the formula for series and parallel combination, right? When in series, current is same. When in parallel, voltage is same. Okay, now current is same throughout the circuit but not the voltage. The total voltage is 10 volt and they're asking us to get the voltage drop across each resistor. Okay, potential drop across each resistor. So which means I have to get the voltage across these 2 points, which I can call as V1 since the resistor I have named as R1, and across this second resistor which I can call as V2, and finally across the third resistor which I can call as V3. Okay, so V1, V2, V3 is what I now need to calculate. Okay, see, you want V1. Let me name the points first as A, B, C. See, now I want potential difference between A and B. Okay, I have the resistance between A and B, which is 2 ohm. And if I can get the current through the resistance, okay, I can easily obtain the voltage using Ohm's law, because Ohm's law says V is equal to IR. So if I apply Ohm's law between the points A and B, the only unknown factor now required is the current, which is same for all the resistors, which is the same, which is the current drawn from the battery. Okay, so first let me work for the current drawn from the battery. Okay, so current drawn from the battery, I is equal to V by R. Okay, I could have put I is equal to E by R plus R. Since small r is 0, E becomes V. Okay, that's why I have directly taken I is equal to V by R. That's also fine. So what is V here? The total potential difference, which is 10 volt. What is R? R is the resistance of the entire combination. Okay, I'm talking about main current. When I talk about main current, I should have the effective resistance of the combination. Okay, what is R? R is 9 ohm, the effective one. Okay, so the total current or the main current drawn from the battery is 10 by 9 ampere. And this 10 by 9 ampere is same for R1, R2 and R3 because they're in series. The same current flows. Nowhere the current is splitting, right? So it's the same current which flows. So you have I is equal to 10 by 9 ampere given, obtained. So now applying Ohm's law between the points A and B. Okay. So between the points A and B, what is the resistance? R1, which is 2 ohm. Between the points A and B, what is the voltage? That has to be calculated, V1. And between the points A and B, the current is I, which is same for all the resistors, which is 10 by 9 ampere. So Ohm's law says V is equal to IR. V1 is equal to IR1. Current is 10 by 9 into R1 is 2 ohm, which is equal to 20 by 9 volt. Okay, 20 by 9 volt is the voltage drop across the first resistor. You can make use of calculator to get the actual value. It will be somewhere around 2.22 to recurring. Okay, so V1 we obtained. In the same way, work for voltage drop between B and C. Okay, so between B and C, V2 is equal to IR2. What is I? I is same for all resistors, which is 10 by 9. What is R2? R2 is 3 ohm, right? So it's 3 ones are 3 threes are, which is equal to 10 by 3 ohm, which will be 3.333 ohm. Okay, so you have V2. The same way between sorry, it's not between B, yeah, C should be kept here and this point should be named as D. Okay, now between C and D, okay, this points, this is B and C, between C and D now, which I called as V3 is equal to IR3, current is 10 by 9 into the resistance is 4 ohm, is equal to 40 by 9 volts. Okay, so these are the voltage drops or the potential drops across each resistor. Clear with this? Now in order to verify whether the voltages are same, you can do one thing. You can add V1, V2 and V3 together. Okay, it's 20 by 9, 30 by 9, 40 by 9. Add them together. Or how much will you get? 20 plus 30 plus 40. How much? 90. Isn't it? 20 plus 30 is 50 plus 40, 90. 90 by 9 is 10 volts. We have obtained the complete voltage, right? 20 by 9, 30 by 9, 40 by 9. Add them because it's V1 plus V2 plus V3, which is equal to total voltage V, right? Because they're in series. So the total potential drop is 10 volt, which we can obtain even after simplifying, even after adding the individual voltage drops. Clear? So, which means that the potential is dropping this much, this much, this much every time it crosses a resistor. Okay. So these are the final answers: V1, V2 and V3. This is the answer for first part, 9 ohm. Clear? Okay, moving ahead, the next question number 22, which has two parts in it. First part of the question says, 3 resistors, 2 ohm, 4 ohm and 5 ohm are combined in parallel. What is the total resistance of the combination? Okay, very similar to the previous. In the previous problem, it was series, now it is in parallel. Next, in the second part of the question, if the combination is connected to a battery of EMF 20 volt and negligible internal resistance, we are safe. It's not that complicated. Internal resistance is 0. Determine the current through each resistor and the total current drawn from the battery. So this question is very similar to the previous question. In the previous question, it was in series combination and they ask us to get the voltage drop across each of them. And in this, it is the parallel combination and now they are asking us to get the current through each resistor. Okay, right. So first, let's go for the first part of the question. In the first part of the question, we have 3 resistors. Three resistors, 2 ohm, 4 ohm, and 5 ohm connected in parallel. Okay, let me include the second part also. And they are connected to a battery of EMF 20 volt and 0 ohm internal resistance, no internal resistance. Okay, this is the given data in circuit form. Okay, the first part of the question is finding the effective internal resistance. Okay, again parallel combination, and we have 3 resistors, so I'll go with 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp is equal to, what is R1? R1, let me take this as R1, this as R2, this as R3. So it is 1 by 2 plus 1 by 4 plus 1 by 5. Okay, what is the LCM? 20 is the LCM, right? So 2 10s are 20, 4 5s are 20, 5 4s are 20, which is equal to 19 by 20. Okay, this is Rp, 1 by Rp. Okay, keep that in mind. So Rp is 20 by 19 ohm, which is close to 1.1 or even less than that, 1.05 ohm. Okay, you can make use of calculator to get it. So we have Rp with us. The first part of the question is answered. Clear. Okay. Now coming for the second part, what do we need to calculate? We need to calculate the current through each resistor, which I can call as I1 through R1, I2 through R2, I3 through R3, and also the main current drawn from the battery, which I can call as I. Okay, so let me target the main current first, because we have the resistance of the entire combination, we have the voltage drop across this. Okay, and also let me name the points as A, B. Okay, for the entire combination. So this is just for the reference. These points are common. Okay, A, C, and between C, these 2 points I've named as C and D. A, B, C, D, E, F, G, H. Okay, so between A and B you have the entire combination. So between A and B, okay, see, actually A, C, E and G are all common points. They're all at same potential. Okay, just for the reference I've named them differently. Okay, so between A and B, what is happening? The entire resistance is Rp, which we have obtained. Rp is 20 by 19, right? In the same way, the voltage between A and B, the voltage is 20 volt, and it is same for all the resistors, 20 volt, 20 volt, 20 volt, 20 volt. So resistance voltage is 20 volt. What we need is the main current drawn. So from Ohm's law is equal to V by R. V is 20. R itself is Rp for the main current. Okay, main current means for the entire combination, Rp. So Rp is 20 by 19, 20 cancels, 19 ampere. So 19 ampere is the total current drawn from the battery, total current drawn. And now this current is split into 3 parts, I1, I2, I3. And individually they travel and come back as 19 volt here again, 19 ampere once again. And now we are looking forward to get the values of I1, I2 and I3. And we are going to make use of same format. So now between G and H, okay, I have named them as A, B, C, D, F so that you have the clarity how are we applying Ohm's law in the circuit. Okay, and it's not necessary that you should have something, the names like that. Okay, it's just for the clear understanding purpose I have taken. So it's between G and H now. What is the voltage between G and H? It is 20 volt itself, because they're all common points and it's the parallel combination. So voltage is 20 volt. Okay, I'll directly write the formula. I is equal to, I is not I, it's not simply I1. I1 is equal to V by R1 this time, which is between G and H, the resistance is 2 ohm, okay, between these 2 points. Particularly, I'm talking about this branch. And between G and H, the current is I1, right? So I can write I1 is equal to V by R1. What is V here? 20 volt, common for all of them, divided by, what is R1? R1 is 2 ohm. So I1 is 10 ampere. So out of the 19 ampere main current, 10 ampere flows here. Okay. And similarly, now between E and F, okay, between E and F, I2 is equal to V by R2. What is V? Again 20 volt. What is R2? R2 is 4 ohm this time, right? So it's 4 ones, 4 5 7. 5 ampere current flows through the second resistor now. Okay. So 2 currents are found. Now how do you get the third current? You can go with the same method. Okay, I1 is equal to V by R1, I2 is equal to V by R2, and similarly between C and D, I3 is equal to V by R3. Voltage is common, 20 by 5, so it's I3 is 4 ampere. Okay, or else you have main current coming I 19 ampere out of and this 19 ampere is the current entering the point A. The current leaving the point A is I1, I2, I3. So you can also make use of I is equal to I1 plus I2 plus I3. Okay, and you have I1 plus I2, 10 plus 5, 15, and I as 19, and hence I3 you will get as 4 ampere itself. Okay, that is also fine. That can also be used. And this is also fine. Okay, you can make use of Ohm's law directly between C and D and get the current through 5 ohm resistor. Clear with this? So we have answered all the questions. Current through each resistor and the total current drawn. Total current drawn is calculated initially, which is 19 ampere. And current through each resistor is calculated here. I1 10 ampere, I2 5 ampere, I3 4 ampere. See, now you add all of them, you'll get the main current. 10 plus 5, 15 plus 4, 19 ampere, which is the total current. So 19 ampere current comes here and splits. Out of 19 ampere, 4 ampere goes here, and 5 ampere goes here, then 10 ampere goes here. Okay, 4 plus 5 plus 10, 19 ampere again comes back. That's how the current flows. Okay, so these are the answers. Okay, the next question, 23rd, is more like a complex circuit, but it's actually easy. You should cut it down so that you can do it easily. Okay, let me read the question. In the given circuit, okay, so for this problem, they themselves will give you the circuit. Okay, don't need to worry in drawing. So they have given the circuit in the question itself. In the given circuit, calculate the effective resistance between A and B. So between the points A and B, the effective resistance has to be calculated. There are so many resistors connected in different ways. We'll work on it. Then in the second part, current through the circuit, which means the main current drawn from the cell, okay, which I can call as I. And then current through 3 ohm resistor, okay, which is this current, which I can call as I1. Okay, so first let me go for effective resistance, which means the net resistance or the total resistance between A and B. Let me go for that. So look at this, between A and B we have so many resistors connected, but we will look for the primary combination or the basic combination that we have. Okay, see, first we have this 12 ohm and 8 ohm connected in parallel. This is simple part of the circuit. We will solve this, and then we will go for 4 ohm and 6 ohm, which are also connected in parallel. We'll solve them, and then we will have this combination and this combination in series. Okay, we will work on it, series combination. So we will have one resistor in place of the entire of all this combination, and then we have this resistor 3 ohm and 2 ohm in parallel. You work for parallel, we will get it. Okay, Clear about the strategy? So first, the simplest part of the circuit, we will look for the simplest part of circuit. Simplest part of the circuit is this 12 ohm and 8 ohm in parallel. Okay, so let me call the effective resistance of this combination as RP1. Okay, and okay, let me name all of them. Let me name this as R1, R2, R3, R4, R5, R6, 6 resistors in total. So RP1, I will take the effective resistance of this as RP1. Why RP1? Because we have two parallel combinations again. So RP1 is equal to R2, R3 divided by R2 plus R3, right? Isn't it? Two resistors in parallel. So what is R2? R2 is 12 ohm. R3 is 8 divided by 12 plus 8. So it's 12 into 8 by 20. Right? So it's 2 4s are 4 4 4 2s are 4 5s are. Right? So it's 12 2s are 24 by 5 ohm. Okay. So 24 by 5, you simplify this, make use of calculator, okay, which will be equal to 5 4s 0.8 4.8 ohm. Okay, so that is what is RP1, the effective of this two. Similarly, I'll work for the effective of these two now, of R4 and R5 in parallel, which I will call as RP2. So RP2 is equal to R4 R5 by R4 plus R5, which is equal to, what is R4? 4 ohm. What is R5? 6 ohm. So it's 4 into 6 by 4 plus 6. 4 into 6 by 10. Okay. So 2 2s are 2 5s are, right? So it's 2 6 are 12 by 5, which is equal to, okay, you can keep it 12 by 5 ohm, which is also equal to, or if you divide it, it is going to be 2.4 ohm. Okay, so you have RP2. Now, if you want to visualize the circuit looks somewhat like this. You have 3 ohm here, okay, and you have these two, 24 by 5 and 12 by 5. Okay, and then you have 2 ohm. Okay, this is how the circuit has reduced. Now this 24 by 5 are 4 by 4.8 ohm and 2.4 ohm. These two resistors, RP1 and R2, these two are RP1 and RP2. They are in series now, right? This combination and this combination are in series. So let me name the effective resistance as RS, and hence RS is equal to RP1 plus RP2. Now what I am getting is the resistance from this point to this point of this branch, entire this branch. Okay, RP1 plus RP2. What is RP1? It's 4.8 plus, what is RP2? It's 2.4. So which is equal to 4 plus 8 is 12. 4 plus 2 6 plus 1 7.2 ohm. Okay, so 7.2 ohm is the resistance of this entire combination, leaving 3 ohm and 2 ohm. Just leave 3 ohm and 2 ohm. This 7.2 ohm is the resistance of this combination. Okay, I think it's better if I keep it in the ratio of this itself. It will be easy for me to solve, because I'll be getting 1 by 7.2 and all. Okay, if you have calculator, since you will be having calculator, you can work with that. Okay, so if I keep it in fraction, 24 by 5 plus 12 by 5, which is 36 by 5. Okay, so now you have obtained the resistance of this entire combination now. Okay, and now this 3 ohm and this combination and this 2 ohm, these three are in parallel, right? So finally I can write 1 by Rp is equal to 1 by R1, okay, plus 1 by, this entire combination is named as RS. Okay, RP1, RP2, RS. 1 by RS plus 1 by R6 finally left. Okay, so what are the values? It is 1 by 3 plus 1 by RS. RS is 36 by 5. So 1 by RS is 5 by 36 plus R6 is 2 ohm, 1 by 2. So 36 itself is the LCM. 12 3s are plus 5 plus 18 2s. Okay, simplify this. 12 plus 5 is 17. 17 plus 8, 25. 35 by 36 is 1 by RP. Okay, keep that in mind. Should be very careful while keeping the final answer. So 1 by RP is 35 by 36. What is RP then? So RP is 36 by 35. Okay, it's very close to 1. Okay, very close to 1. 36 by 35 ohm. You can keep it 36 by 35. This is the resistance of the entire combination of all the 6 resistors put together in this form of the circuit. You get the final resistance RP, which is equal to 36.5 ohm. Okay, right, let me work for the second and third part of the question now. Okay, second part of the question asks us to get the current through the circuit, main current through the circuit. Again, it is quite easier for us since they have not given any internal resistance of the battery. It's negligible. So 12 volts itself is the potential difference or voltage across the entire combination. So 12 volt is the potential difference that we have across the combination between A and B. And applying Ohm's law between A and B, okay, Ohm's law between A and B. So now you have, what is the effective resistance of the entire combination? Effective resistance of the entire combination is found RP, which is equal to 36 by 35 ohm. And what is the voltage across these 2 points? Between these 2 points, 12 volt. V is 12 volt. And current has to be found, which is the main current drawn from the battery. Okay, I, the total current drawn. So again, Ohm's law says I is equal to V by R. Here it is RP. So V is 12 volt. RP is 36 by 35. Right. So it's 12 ones are, 12 threes are, 35 goes to the numerator, 35 by 3 ampere. Okay, you can simplify it. It will be 10.6666. Sorry, 11.66, 11.67 ohm, no, ampere. Okay, so this is the main current drawn from the battery, from the circuit, or I can say current through the circuit. Okay, current, whenever there's current through the circuit, they are referring to the main current itself, nothing else. Okay, main current drawn is found 11.67 ampere. Now one more question remains, third part, current through 3 ohm resistor. Okay, so between these 2 points, which let me name them as C and D. Okay, so now applying Ohm's law again between C and D. Okay, quite easy. What is the potential difference or voltage between C and D? See, now you can observe C and A are common points, no components between. And similarly, D and B are common points. Okay, in simple words, it's again parallel combination. When you have parallel combination, voltage across individual components, okay, between C and D, between A and B, and between these 2 points. Okay, observe carefully here, between these two, and between these two, the voltage will be same. Okay, so I can say the voltage between C and D even now is 12 volt itself, right? And the resistance is 3 ohm, and the current has to be calculated. Current through that 3 ohm resistance has to be calculated. Again, Ohm's law itself will help us. I1 is equal to V by R1. V is 12 volts, R1 is 3 ohm, which is 4 ampere. Okay, so I1 is the current which is flowing through this 3 ohm resistor, which is equal to 4 ampere. So similarly, you can work for current through this 2 ohm resistor. How much it will be? It will be 12 by 2, which is 6 ampere. Okay, so through this you can work it out. It is not asked in the question, you can work. So through this part you have 6 ampere current flowing, and here we have calculated it is 4 ampere. 6 plus 4 is 10. How much is left? It's simply 1.67 ampere left, and that 1.67 ampere will split here, recombine, again split and recombine. Again this 1.67 will combine with this 4 ampere and 6 ampere again and comes back. Okay, and if you are interested, you can even get the currents through this 12 ohm, 8 ohm, potential difference between these 2 points. Okay, it all can be done. Okay, you do it as a practice. Okay, so that's about the third part. 4 ampere is the current flowing through 3 ohm resistor.